All right, thank you. So I'm mostly going to be talking about speed index. This may or may not be new to you. I talked about it a little bit in my talk yesterday, but it's something we've been pushing for probably about the last year when we've been looking for a better way to represent the user experience than the onload event. And this is kind of an old slide with kind of old screenshots. I had to put an old Twitter in front of it. This is back when Twitter was still doing Bootstrap and not doing any server-side rendering. They'd send down all the JavaScript, and then they'd pull down all of the AJAX content, and then they'd finally render the user content. And the onload event for that was, a completely blank screen. They had a toolbar, woohoo! So they've been using their own custom metric, time to first tweet. But this is a great demonstration of what happens when you use onload as your endpoint. Especially in the AJAX cases, it means nothing. In the case of Engadget, this goes the other way. This one has a 10-second onload time. But at 1.7 seconds, the bulk of the content is loaded. And if they were optimizing for the onload time instead of the user experience, they'd be in kind of a world of hurt because they'd be optimizing. Engadget's one of those really long scroll blog pages that has 50 images down 3 folds down below the fold. And if you start optimizing and trying to bring all that in sooner, you can start competing with the above the fold content. And we wanted a way to be able to measure this sort of objectively and be able to test across sites without having to custom instrument every single site that we were going to test to see how we were doing. This is kind of a completely fake but a good experience for demonstrating exactly what I'm talking about. I staged, this is web page tests UI, and I put in sleeps in various different points to show you what can happen to the UI even with identical technical metrics for everything we've ever been measuring before. The start render, the one on the left, it's got most of the content. The one on the right, it only has the toolbar. This actually happens scarily more often than you'd like on the web. The onload time, also identical, happens at 12 seconds for both of them. The last change that happened on the page above the fold, so prior to speed index, we were using an AFT metric above the fold time, where we try and measure when's the last thing that happens above the fold on the page. We'll count that as the visual time for the page. In this case, it was the tweet button that showed up. It just happened to show up 12 seconds later. I doubt my users would ever even notice that that button showed up or didn't show up. So one of the things we added with web page test, we started calculating how complete is the page visually above the fold. And if you go into the film strip view whenever you record video, down below each of the film strips you'll get the estimate of how complete web page test at least thinks your page is at any point in time. And it can sort of calculate those over time. And if you plot it, it kind of becomes completely obvious which one of these is faster, right? The red line's the one that displayed almost nothing until the end. The blue one displayed almost everything right before it was complete. So we basically take those things, we look at the area above it, and we go, okay, that's going to be our speed index. Technically, it kind of boils down to sort of the easier to explain. I've had a lot of trouble trying to explain this abstract sort of number to people, especially management. It's the average point in time when something above the fold painted. So it is a point in time. It's measured in milliseconds. The one on the right, the 9,000 plus speed index, if you average out when the toolbar showed up and when the rest of the content showed up, including the area for the pixels, it works out to about 9 seconds. So it's neither the 1 second or the 12 seconds. It includes how quickly you're painting the stuff above the fold. And it's exposed in web page test in the main metrics. You'll get it anytime you record video. You'll also, when you go to the film strip view, down below the film strip, like I mentioned, you'll get the visual progress. You'll also get the graph showing you how quickly things painted. So you can see, you can compare when you're looking at multiple sites or multiple versions of the page against each other. You can compare the above the fold painting against each other. So in this case, Engadget speed index is effectively 2.3 seconds. So somewhere right after that start render, the 4.2 seconds is when most of the above the fold content was there. Somewhere in between those two, compared to their 10-second onload time. It's still not perfect. It kind of depends on you being able to guess what percentage of the above the fold is complete at any point in time. Pages that have a gallery that rotate every couple of seconds When is it 100% complete? When's it 50% complete? The code's not perfect for doing that part yet. Interstitials, if you have a huge ad that covers the entire page right at the end. In web page test, at least right now, there's 2 versions of the calculation, but in one of them you will get 0 credit for all of the content you loaded before that interstitial shows up. And it's only available in a lab for now. We're working on a RUM implementation for now. So we use this pretty heavily for optimizing Chrome as well. We'll optimize for delivering content that's above the fold rather than the full page load times. We've started doing the Chrome scheduler, resource scheduler. When it fetches resources off the net for your page, we've been trying to optimize it for doing the above the fold. Speed index is the main metric we've been using for that. And we're working on instrumenting Chrome itself to be able to report this back so we can measure it from the field. And hopefully, if we can avoid any security problems with exposing it and privacy concerns, hopefully we'll be able to expose it to the DOM as well. We're running a little late, but that was it for me. I'm going to kick it over to Ray, who's going to talk about Microsoft's been doing a lot of work in this area as well, and he's got their version he wants to share with everyone. Yeah, you can hold it. We're planning on doing maybe 10 minutes each, and then we'll have a Q&A where we can all answer all of your questions.
Thanks, Pat. Wouldn't it be cool if we have a rendering performance measurement that tells you when a normal user thinks this page is done, just like what Patrick just showed? Or, for example, Facebook. I bet most of you will say Facebook is pretty fast. It's damn fast at 1 second or 2 seconds. But if you test the AFT, it's going to be like 4 seconds, 5 seconds, or even infinity. Or the onload is being super long. So wouldn't it be cooler if it is cross-browser, device independent? So today we want to solve this problem. We want to solve the dynamic web page rendering problem, like some ads being boom, pop up. Or we want to have it like a cross-device browser independent. So how are we going to solve this problem? First, we want to categorize the whole page load cycle into a series of phases, like big chunks, and determine which phase really best represents a user's perception of performance. So let's take a look at a famous example, Amazon product page. I searched for Steve Saunders' book on Amazon, and this is the product page it renders. So this is a screenshot that everyone understands. I already eliminated those like different screenshots, but only keep those like big changes. So starting from 0 seconds, I initiate the request until 1.7 seconds. It starts to render the search bar and the right rail, and 0.1 second later, I got what I want as a normal user. I got Steve Saunders' book. I got a title. I got a price. 0.4 seconds later, 2.2, it starts to render some content below. For something like people bought this book, also like some other books. Then for another 2 seconds, it changes to some other content. By the way, this page onload is 4.7 seconds. So the problem is, how do we categorize this whole page load cycle into these 4 phases? That's pretty obvious. And the next problem is, how do we tell on behalf of user at 1.8 seconds, that number is what we really want, this absolute number. So let me introduce another extreme case, which is my favorite. This is a more dynamic web page, and it is a real case given by one of my friends in Amazon. He said, hey, Ray, tell me what is the PLT for this page. So I took a series of screenshots and plot on this slide. Take a look at it. It's being super dynamic, starting from the widescreen. At 1.3 seconds, it starts to render the brownish background, then render a nice beautiful called flash for another second. Then the flash disappears, render the real background for about another 0.8 seconds, then start to play a video. So I said, there's no way for me to tell that because this page is being super dynamic. Should I use AFT? No, I can tell you this video is about like 8 minutes. I'm not going to tell him it's 480 seconds for the PLT. He's going to really kill me. So I said, okay, why don't I just categorize the whole page load cycle into several phases and get their timing. So I came up with the idea of page phase time. So I'm going to give a quick demo about the page phase time thing to give you an idea of how it really works. So I'm going to pause for 5 seconds in case you want to type this URL. So this is a demo site we've been built only for Velocity, and it will be there for another 30 days starting from today. And here is a sample I'm going to show you. It's about O'Reilly.com. So let me switch to Chrome. Oops. Just 1 second. Can you see that? Okay, so let me tune the size a little bit smaller. Is that better? Okay. So this is a demo site just for experimenting the page FaceTime concept. And we've been doing that for the last 1.5 years and on over 1,000 different pages in the industry. Basically, you can submit a URL, something like this, by typing, say, google.com and submit it, just like web page test. Then I'm going to cheat a little bit because I already prepared the results for the O'Reilly.com. So let's quickly spend 10 seconds to take a look at the video record of this page. So pay attention to the top right corner, which indicates the timing. So total will be 10 seconds. Right now I'm at 0.5 seconds. I'm going to pause a little bit slowly. 1.4, 1.7, about 2 seconds. Boom, almost everything gets rendered. Then let's pay attention to what happened later. Slowly render some like new books and videos at the bottom. Then take about another 8 seconds. Boom, renders another big image. Yeah. So usually if you use AFT, you will probably end up with the AFT being like 10.5 seconds. And as a normal user, as everyone sitting here can tell, at around like 2 seconds, you get mostly whatever you want. So this tool actually intelligently categorizes the whole page load cycle into these two phases on the left banner I'm showing. Is called page view. The phase 1 is pretty precise. It's 1.989 seconds. You get almost everything you want. Phase 2 is another big change, which is like around 10 seconds. Even beyond that, this tool tells you, hey, you have 2 phases, and I guess you may like only one number to report to your manager. And it picks up intelligently that phase 1, the first phase, here, see here, first one? First phase is the phase that you want, and its corresponding timing is 1.99 seconds. So that is the absolute number page FaceTime is giving you to tell you that on behalf of user, hey, when a normal user would think this page is done. So let's come back to the slide. Oh, by the way, I haven't finished my demo yet. Even with telling the phases, we want to enable our developers to easily troubleshoot their rendering performance issues. So we align those phases timing, just like HTTP Watch, you can get onload, first render, or blah, 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 those vertical lines plotted on the waterfall graph. We also have those phases. This is HTTP load. Phases being a vertical line, a line with, it's pretty small, yeah, and then you can hover here on the phase 2, along with your waterfall, chart. For example, if you are not satisfied with the phase 1, which is being too slow, say 2 seconds is too slow, you might want to troubleshoot by looking at the closest request that download before that vertical line of phase 1. Then you can tune correspondingly. And this helped us tune a lot of rendering performance issues for different Microsoft websites. And what's really working on the back end? Let's solve the mystery. So it's only 3 steps. It's not too much different from what Patrick does. First, we capture a series of screenshots of video frames or of the whole page load cycle. Second, that's a distinct part. We categorize them into a series of phases, each representing a substantial rendering change. Lastly, we want to determine which phase best represents a user's perception performance based on which phase has the greatest effect on the most important part of the screen. Because not every pixel counts, or not every pixel weighted the same on the page. You want to focus on some important area. The first one, I'm not going to talk about how do we capture screenshots because most of us know how to do it already. So we want to focus on how do we categorize the phases out of those given screenshots. For example, you can give me a video record or screen captures from webpagetest.org, and I can easily categorize that for you. So phases are determined by calculating the pixel change acceleration and finding the outliers beyond one standard deviation plus mean. So what does that mean? Let's give a more human understandable explanation. Imagine we record the whole page load cycle, which is like 10 seconds, at 10 frames per second. So basically you get 100 screenshots. Then you want to compare each screenshot one by one next to each other, and then you will get an array of 99 elements into a double array. For each of the elements will be the pixel changing percentage, which I call pixel changing velocity. So I plot onto the graph and see something like this. Starting from 0 to 0.6 seconds, it has a 60% of the pixel change, and then at 1 second, a 70% of the pixel change. And what's more interesting, starting from 1.5 until 2.5 seconds, it is constantly changing the pixels around like 45%-ish. So it is, as you can imagine at this moment, it is pretty common. A lot of the dynamic web pages, especially portal pages, home pages, like starting from 0.5 seconds, render some background, boom, being black, being blue. Then 1 second, major content rendered. Starting from 1.5 seconds, for another second, it renders something like a dynamic content, like ads or video or animated flash. But if we stop at this stage by setting a static threshold over here, so we may end up with something like, if we set a static threshold to be 30% pixel change, that meaning all the dots beyond 30% will be the phases, then you will end up with like 17 different dots, which is not that you want. So how can we solve this problem? Back to the definition of phases. Each phase should represent a substantial rendering change. What is a substantial rendering change? Substantial change, meaningful change, drastic change, fast change. Right. Change itself is a velocity. What is a fast velocity? You're right. Acceleration. It's just taking one step further, to do a calculation based on the first chart, and then minus the numbers next to each other one by one, and then plot into another graph. Basically, you get 98 acceleration numbers out of the 99 velocity numbers you already got. Then the final step will be figuring out those outliers. Those outliers will be phases. So at this moment, you may want to ask me, hey, you give me 3 phases. Which phase should I use? So we came up with the idea of key phase, the most important phase that best represents a user perception performance. So usually we will choose pick up the first phase that around the golden section or the most important area of this page, and that has the most substantial content rendered. So it can also be some other areas of this page, and then figure out those areas among all those 5 phases. So this time we're going to use the velocity numbers and pick up the first outlier to be the key phase. So that's pretty much enough. It's pretty simple, but it's pretty useful. We've been experimenting that a lot, and it's been proved pretty accurate for like 90% above the page. We don't guarantee 100% working, but you can definitely try the site I've already showed to you. It's ppt.msn-dev.com. So let's make a quick summary. So PPT, like page FaceTime, is not PowerPoint. It's a unique method for automatically measuring the user perception of web page performance that relies on categorizing a whole page load cycle into a series of phases. And this enables us, like performance engineers, to troubleshoot those like rendering issues, and it does not depend on any static thresholds. And it can help us accurately measure those like dynamic pages, like social buttons being pop up, boom, at 5 seconds, or anime ads, or flash, etc. So if you have any question, just tweet me or email me. Thank you.
Okay. Oh. Okay. So there's a theme here with a lot of the stuff we've been looking at with measuring real user performance. it seems to be very contextual and based on the context of the user and the app. But from what we've seen with our current existing metrics, like DOM content loaded and onload, these aren't very contextual, and they're not consistent when measuring real user performance. As you can see here, Facebook and Google at at DOM content loaded and onload, they're not very ready. So we really need a better metric for measuring context specifically when the user can actually use the site. So let's embrace that and say that when the page is done is user ready, when the essential elements on the page are ready for the users to use. So let's take an example. This is an e-commerce site, and there's a lot of stuff going on here, ads, banners, but really the only essential elements of this page are these ones. Everything else is additional. Without these elements, though, the page is considered broken. Most users won't be able to use it. They'll try to refresh or navigate away. So these are really the essential elements of the page that really need to be present and actionable in order for the page to be considered done. This is our site. This is AYI. It's a dating app. And here, the really essential elements of the page are really just these two, a notifications bar and the current profile with an option to like them or skip them, as well as you can just view basic info. So we've identified kind of the really important parts of these pages and that are really essential to be considered in order to consider them done and ready for the user to use. But how do we actually measure this programmatically? So let's take a look at this example again. So here, this page is done when the buttons are rendered, they can be clicked, all the event handlers are bound, the text is there, and the image is fully loaded. So to do that in code is pretty straightforward. Here we have, we just populate the DOM with the HTML, we bind the event handlers, and in a load callback for the image, that's when we set the page as user ready. So pretty straightforward. But what does setting it user ready actually do? So again, relatively straightforward. Basically, all we do is we get the performance timings of the page, as well as the current time, and we just ship that off to any sort of analytics platform, Google Analytics, Mixpanel, Soasta. For newer browsers, you can use the navigation timing API to get some more fine-grained control. But there's also a fallback here if you're using an older browser that doesn't support the navigation timing API. So this lets you retrieve and log real user metrics around when the user can actually use a page. So we did this with AYI, and this is what we got. So there are 3 lines here. The bottom one in blue is DOM content loaded. Above that is onloaded. And it makes sense, onload usually takes longer. But then we see user ready way above that, from 6 to 10 seconds, which is crazy. 10 seconds for users to be able to use the site. And so this was really eye-opening to us, because before this, we just thought, oh, it takes about 6 seconds for users to be able to interact with the site. But no, because the way we've architected the site, it actually takes a lot longer. So this is very insightful and helps us really realize how important performance is and what the actual end-user performance of the site is. So this is great. We've identified how the performance fares. But how do we actually use this data to improve it? And that's where the next step comes in. So let's take a look back at the homepage here. This is the homepage of AYI. And we've identified that the most important content is the user's profile and the action buttons. But there's a lot of other stuff on this page that's being loaded as well, such as this priority inbox sidebar with lots of images and content, more images underneath the user's main profile picture. All this stuff might be loaded in parallel, might end up being loaded before the main content, depending on the browser. So we need to ensure that it doesn't hog the same resources as the main elements and prevents them from being downloaded fastest. So we can do that. Since we've already identified in code when this page is user ready, we can actually defer the loading of these additional elements until after user ready is triggered. So we do that by simply extending what we've already written so far. And here I'm using a promise. Basically, I attach a callback that, when executed, loads this additional content, such as the additional user photos, the mail sidebar. And that promise is only resolved once user ready is fired. So that ensures that none of this ancillary content impedes or competes with the primary content of the page. So it ensures that we get through the primary and the critical path as fast as possible. So in conclusion, there are a lot of benefits to this approach. Not only can be used in synthetic environments, but also real user monitoring, as shown here. It can be easily integrated with analytics platforms such as Google Analytics. You have really fine-grained control over precise loading order. It works in all browsers. However, because it's context-sensitive and context-specific, you do have to manually define it for each context or critical path that you want to measure. But that's the nature of the beast with the way performance is measured today, because we no longer have just simple apps with scripts, with one script, synchronous script tag and static HTML.
All right, we've got about 8 minutes for questions. I'd also say we've all got office hours right after this upstairs, so if there's anything you wanted to chat about in not quite such a public forum, feel free to follow us upstairs right after, or not right, it's right outside, never mind. So any questions? Right up here. So the question was, how do you handle rotating banner ads?
Okay, before I answer your question, can I quickly use a Chrome to show you one favorite example I have that will answer your question. Does anyone play Warcraft? Uh-oh, is that out of network? Okay, it is supposed to be a super dynamic web page. So for those rotating ads or whatever being dynamic, or even sometime for like Google homepage, if they want to display a blue banner, you want to set this as a default browser or improve user experience, or something like MSN shifting the whole page by like 15 pixels for some ads. Those kind of animation, we already solved the problem by, if it is changing too fast, which is usually not the case, your user don't want it. We already omit those fast changing, which is like adjacent to each other. But if it is changing slowly, it will depends on how big the change is in terms of the screen area. And then we'll determine, okay, whether that should be counted as a phase or not. So you may want to experiment that by submitting a test on the demo site ppt.msn-.com to try that out. Yeah, it might not be 100% perfect, but it already categorizes that. So by removing those adjacent phases, it's another amendment to the algorithm. To answer your question?
Yeah, I wasn't sure how that was handled.
I think that's too detailed. Maybe we can discuss that detail in the open office. Yeah.
So we're talking about what is visible, trying to detect what is visible in the not for the end user. But as you know, the web might be visible but not visible. So is that you see it being another metric, or how do you see that fitting into this question?
So the question was, we've talked a lot about visible, not so much about usable, although Mike talked about usable in his talk. And is that a separate metric? At least as far as the speed index is concerned, no. The hard part is knowing sort of universally across the web without having the context of the app itself, knowing when is it actually usable, right? When have the click handlers been attached? Are the click handlers necessary for usability? That kind of stuff. So I don't think we have a really good answer for that right now. DOM content ready is usually a good proxy for a lot of that, but it also depends on how dynamic you are about attaching stuff after onload, for example.
Actually, I would say that functionality is very important. One example is Facebook. While it's loading, you oftentimes see the bar with notifications, and so many people would click that before the events were bound that they actually added some logic to actually capture and kind of queue up any clicks that users would do before the handlers were actually bound. And then they play those back so you kind of re-emulate those same clicks. So I think it is very important. Well, again, it depends on the context.
The example you showed is by JavaScript, right? So you're kind of controlling those elements using JavaScript. But on a normal web page that we do, like what you're showing here is a dynamic application where you can control each of them. On a normal HTML page where you're necessarily not creating those using JavaScript, like those sections, how do you kind of control that?
So there it's a little easier. So in essence, if let's say you only want to see whether images were loaded or some video loaded, then you don't need the first part. You can just see, oh, when these images have loaded, then it's done. If you only care about content, in a lot of cases, it's simply like a simple Google Analytics call in the same fashion.
What about resolving it? Like you talked about the resolution part of it, where you're actually controlling how elements don't compete with each other.
Mm-hmm.
How can you solve for that? You can read when what was fired, or how do you solve for that?
Oh, so it is harder if all your HTML is static, because then the browser preloader kind of kicks in and starts loading stuff on its own. So you have to do some tricks to either hide that content or dynamically load that in. But sometimes that's beneficial. Sometimes it's better just to load everything up front if it's not too much data.
Really quick on that part, if it's mostly a static site, I'd strongly encourage you in the HTML itself to try and put things in the order that you want them loaded in and just let the browsers do the right thing. There are I don't know if you saw this morning in the W3C, there's the lazy load and postpone attributes, which in a completely static environment you can also use to avoid trying to do something fancier with JavaScript about hiding the content and stuff like that. But for the most part, the browsers are going to load things in the order they discover them, with an asterisk that, like Chrome, for example, no matter where you put your JavaScript, it sees that it's JavaScript. If it doesn't have an async tag, it's going to try and boost that above images and things like that. So if you have any JavaScript that you don't want loaded, competing with everything else, definitely try and tag that as async to tell the browsers this is low priority JavaScript, for example. Sergey.
So how do we identify those moments that we need to track? You mentioned that those particular areas are what's important for the site, and then when codified it in JavaScript to define that. How do you define that these are the most important, and how is that embedded in your development process?
Sure. So often that comes down to a product decision. Now, what is the goal of this page? What are the main elements? So here, this is the goal of this page is to browse and to really go through users, guess them and skip them, and that a lot of times that comes down to the main goals of the page, and then that's codified, like you said, in the code. What was the second part?
How do you adapt that identification into the development process?
Right. So that's one thing we're still working with. This is still a very new metric for us, but I imagine it helps to have a mobile-centric development, because that identifies it right off the bat. Like, these are the most important things on the page, so that anything else is ancillary. But yeah, I don't have a great answer for that yet.
Mike, a follow-up on Sergey's question. So what you're doing is you're defining, like, this is the most important part. All three of you guys are doing this, whether it's above the fold or I think you said the golden area. Are there any kind of numbers pointing to, hey, we tried this and we're seeing user interest really reflected based on using this?
I can answer.
Yeah, so he was asking whether the different ways in which we're measuring when the page is complete, if we've seen any difference in user engagement based on development to improve that.
Right. So basically, I think the answer is this is not something defined by developer or even PM. This is something that lasts in the human history for more than 2,400 years. Why? Because has anyone been to a museum like Metropolitan Museum? You saw lots of paintings, arts. So using golden section area, I don't want to explain golden section. You can Wikipedia that. It's like the most beautiful area, like on the middle, but towards the upper left. You want to paint your most important content in that, around that area, and all the artists throughout the entire human history follow that rule, including your designers in the company. I mean, for web pages. Web pages are another art. So you will just want to pick up the area around golden section, or you can do something alternative like the central, like a Google homepage. And look at this this screenshot. This is a perfect example that your most important content is laid out around the golden section area. So you might want to pick up the area around that place to be the most important content and let your developer be aware of, instead of focusing on the right rail. To answer your question.
Thanks. One last question, and then we've got to run out.
Do you want me to answer that?
Yeah, sure.
Okay, so let me show you one heat map. Basically answers everything. That is not by me. This is by Google study based on more than I think 20,000 users. Google SERP page heat map. This answers your question. So you want to focus on putting a most important content, for example, Google search result page around this area. And human eye will by default pay attention to this area, first, as you can tell, the hottest area. Then slowly move to the other part.
Right. But if your designers didn't, with PPT, you can adjust where the focus is, right?
Correct. Okay, so for example, in page FaceTime PPT, we have algorithm to detect whether your golden section by default has any meaningful image. If not, we choose alternative places like central, right rail for Arabic pages, or even top center, bottom center, this kind of area. So it doesn't matter which place. Yeah.
I think you can also do that by tying them directly to business metrics to see, that's a perfect opportunity to A/B test something right there to see if that different placement is actually beneficial. And performance budget also can help you address that as well. And this also answers some earlier question about how do you get this in development workflow. And if you set a performance budget, it forces you to optimize your most important content first, whatever that is, as well as your business metrics. So you're kind of optimizing both, and that helps you achieve that balance of finding what things are really critical for the business as well as performance.
Great, thanks. Like I said, we'll be in office hours, literally right outside that door if anyone's got any more questions.